All right, this is Honors Algebra 2 Pre-Calculus. We're doing 8.2 in Algebra 2. This is our third and final video in the section. We're plotting points and sketching the graph. So here we're putting all the pieces together. The two things left that you need to know how to do are find other points. So what you're going to do is you're going to use your simplified form, and you're going to pick a few easy x values on either side of each vertical asymptote. If there are multiple vertical asymptotes, you need points on either side of each one. You're going to plug those into the simplified form to get y values out. When you're graphing, you're going to choose a scale that fits all of the info you've already found, right? So all of the holes, asymptotes, points, roots, everything else. You're going to draw the asymptotes as dotted lines, both the vertical and horizontal or vertical and slant. Those are going to be like fences that your graph's going to run around. Picture your graph sort of being a dog in this situation running along the side of the fence. You're going to plot the points that you know, the roots, the y-intercept, the points from your table, and you're going to draw each branch of the rational function through the points that you plotted running along the fences, the asymptotes, right? Graphs never cross vertical asymptotes, but graphs can, in some cases, cross horizontal asymptotes. That shouldn't be your default setting. It shouldn't be where you're thinking first. It only happens in more complicated graphs. And then once you have all your graph drawn and your branches drawn, you want to put the holes in the graph, sort of like potholes that the graph runs over. So let's walk through this in a couple of examples. All right, so switch to the slightly smaller pen. All right, so we're going to find the domain, the holes, the vertical asymptotes, the zeros, the y-intercept, and the horizontal or slant asymptote, and then we're going to sketch the graph accurately by hand. We will check it on a calculator just to prove our point. So here's my argument. I can do some of these things. So let's go back a second to the highlighter, right? So there are some of these things, specifically the y-intercept and the horizontal or slant asymptote, that I can do with the standard form. So I'm going to suggest that I do them with the standard form first, right? So I'm going to find y-intercept and these horizontal or slant asymptotes first. Why not? Why not do the easier thing first? So I look and say, okay, cool, I can find the y-intercept pretty quickly. So let's go ahead and extend this page. Y-intercept is going to happen when x equals 0, right? So if we go up here, when x equals 0, I'm going to get 0 minus 6, and 0 minus 4 on the bottom, right? So I'm going to get y equals 0 minus 6 over 0 minus 4. So I'm pretty sure I get a 6/4 or a 1.5. I don't care if you do 3/2 or 6/4 or 1.5. So my y-intercept is, I'm just going to go ahead and say 1.5. I can look at this and see that the degrees are the same. That means that my horizontal asymptote is the fraction of the leading coefficients. So in that case, my horizontal asymptote is going to be a 3/1 or just a 3. Right, so y equals 3, y equals 1.5. And it means that I don't have a slant asymptote, right? Because if I have the horizontal asymptote, I have no slant asymptote, right? So I should probably erase that first thing because that's unclear. All right, so there's no horizontal, or there's no slant asymptote because if you have a horizontal asymptote, you don't have a slant asymptote. All right, cool. So I've already finished the 3 things I can do with standard form. Great. So now let's go ahead and do the stuff that we can do with factored form. So I can find all 4 of these with factored form, right? So if we go ahead and fully factor, right, I notice that the top has a GCF of 3, and when I factor that out, I get an x squared minus x minus 2. On the bottom, I have a definite difference of squares, so it's an x plus 2x minus 2. So I still need to factor one more step. That's a 2, my bad. I need to factor one more step. I notice that this has to be a 1 and a 2 with opposite signs. Since I want to net a -1, I recognize that it must be an x minus 2 and an x plus 1. So here's my factored form, x plus 2, x minus 2. So this is my nice fully factored form. That's a minus, it's just a little bit hard to see. So once I'm here, I can answer a lot of questions. I can see that the x minus 2 definitely cancels, so that's a hole, right? So there's a hole when x minus 2 is 0, which is going to be at x is 2. So let's go ahead and put the hole there, x is 2. Right? The vertical asymptote is going to happen when x is -2, right? X plus 2 equals 0, x is -2, right? My root is going to happen when the stuff on top equals 0, right? So either 3 equals 0, but that's a lie, right? Or x plus 1 is 0. Well, that's going to be an x is -1. So there's my 0, or my root is at x is -1. Great. The last thing I have to do is write my domain, right? My domain is going to be essentially all real numbers except those 2 values. So I'm going to write x is an element of reals, but x can't be -2 or 2. And that's it. All right, so now I've done all of those things, and the last thing I need to do is sketch a graph. So in order to sketch a graph, I probably need a simplified form of the equation. So if I cancel the x minus 2's out, I get that my simplified form is going to be f of x equals 3 times an x plus 1 over an x plus 2, right? Because the x minus 2's would cancel. So now, and I notice that the vertical asymptote is at x is negative 2, right? So that's relevant. So when I pick my table, and I'm going to come down here a little bit to give myself some room, I need to put negative 2, which is a vertical asymptote, on my table, and I need to pick a couple of easy values on either side of it. So when I say easy values, I mean literally the easiest ones. To the left of negative 2, I should pick negative 3, and I should pick negative 4. To the right of negative 2, I should pick negative 1 and 0. Nice, easy values. And what I'm doing, right, so these are my x values, right? What I'm doing is I'm plugging into 3x plus 1 over x plus 2. I'm plugging into the easiest version. So I could plug into this original, but why? Why not plug into the easiest version of this? So when I plug in, if I plug in a negative 4, I get 3 times negative 3 over a negative 2, right? That seems to be a 9 halves, right? Or 4.5 if that helps. When I plug in negative 3, I get 3 times negative 2 over negative 1, right? Which seems to be a negative 6 over negative 1, or a 6, right? When I plug in negative 1, I seem to get a 0, right? Because that's 3 times 0 all over. So it's 0 over a 1, right? But that's just 0, right? And when I plug in 0, I seem to get a 3 times a 1 over a 2, which is that 1.5. So now what I'm going to do is I'm going to go ahead and put those values on the graph. So I need to put everything together. I notice that the biggest y value I have on my table is a 6, and I don't seem to have any other bigger y values anywhere else. So the biggest y value I have is a 6. The smallest y value I see anywhere is, it seems to be 0. I don't see a whole lot of negative y values. So what I'm going to do is I'm just going to give myself a nice, easy space where I can definitely get up to 6. So 1, 2, 3, 4, 5, 6. Let's go down a little bit farther. Give ourselves some space. Okay, so here we go. I notice that my x values, if I look at all the important values I have on the table, I have a negative 2, and some of my points go back as far as like a negative 4, right? But there aren't any really big positive x values. The highest x value I see is a 2. So really, anywhere in here is just fine. So I'm going to draw my x-axis. That should give me enough space. Excuse my inability to draw a straight line. Okay, so let's go ahead and put some stuff on our graph. First thing I'm going to do is put my vertical asymptote at negative 2. So there's going to be a dotted line that is a fence at x is negative 2. That's my vertical asymptote, right? I need a horizontal asymptote, right, which we'll do in, I don't know, purple, right? So we'll do the horizontal asymptote in purple at y equals 3. There's my fence going the other direction. That's my horizontal asymptote, okay? So now I'm going to plot some points. So here's what I know. I know, we'll use, I don't know, let's just go ahead and use black for the points. So here are the points I know. I know that at negative 4, I should have a 4.5. So let's go ahead and put a dot at negative 4, 4.5. So there's 4.5, right? At negative 3, I should have a dot at 6. So let's go ahead and do negative 3, comma 6. Oh, my bad, there's 6. Sometimes my brain is a little bit off. Okay. All right, so there's negative 3, 6. I know that when I plug in negative 1, I should get 0, which also fits here because that's a root. So when I plug in negative 1, I should get 0. I know that when I plug in 0, I should get 1.5, which we saw both in my table and also as a Y-intercept. So there's 1.5, right? All right, so I use those dots, and what I need to do when I draw my curve is I need to draw my curve so it's like a dog running around the fence, right? So picture the dog's going to run along the asymptotes. So the dog's going to run up along the red line and down along the purple line, and it's going to run through this curve, right? It's going to run through to hit those dots. And it doesn't have to be perfect, but the idea is that it stays in its section of the fence, okay? Down here, right, I have a graph that runs down along the red line and comes up here and runs this way. Now, I know that there's supposed to be a hole when x is 2. If you can spot it before you get to 2, that's great. If you can't, that's what erasers are for. If you accidentally do it in pen and don't have an eraser, then you just draw a big obnoxious open circle and put a note that says, oops, Hogan, that was supposed to be a hole. I'm never really trying to make your life harder based on whether you use pen or pencil or whatever, right? So there's a hole in the graph at x equals 2, okay? That's the idea. All right, so that's one problem, right? So that you can imagine that these are not short problems. They put all of the skills together. Let's go ahead and graph it in the calculator and just verify that we're right. So when we graph this in a calculator, in parentheses, I need a 3x squared minus a 3x. And you should always graph the original because you never know where you might have made the mistake, right? So you should graph the original to see if you accidentally made a mistake. Minus 4. All right, and we're going to go ahead and graph. All right, so there's my graph. Now, you might say, okay, how can I spot a hole in the graph? So an interesting thing about a hole in a graph, you can't use your calculator to find this hole. But if you know where the hole is, you can check if you're right. If you hit trace, I think there's supposed to be a hole when x is 2. So if I hit trace and then 2 and hit enter, look what happens. When I hit trace and 2, there's an x value, but there is no y value. That's because there's a tiny little impossibly small pinhole in the graph that you can't see. On either side, if I trace, you'll see there's values, right? On either side, there's values. But if I hit trace and try to go to exactly where I suspect the hole is, you're not going to get a value, okay? The same thing would happen if I hit trace and try to hit negative 2. Same thing, there's a vertical asymptote at negative 2. That's why the graph has no value, right? But you can kind of see how that works out, right? You see that it looks like our graph, and I could certainly change the window on the calculator to confirm that it's exactly the same, but you get the gist. All right, so in P5, we're going to go ahead and do the exact same thing we did in E5. We're going to start with the stuff we can identify quickly in standard form. So we can easily see the Y-intercept, the horizontal asymptote, and slant asymptote in this standard form that we already have, so we should start there. So the first thing I notice, all right, so the first thing that we notice is that the y-intercept is what's going to happen if I plug in x is 0, right? So this y-intercept, right, this literally just means that I plug in x is 0, right? And if I plug in x is 0 for the y-intercept, the 2x squared, the 7x, those are going to be 0. The x squared and the 2x are going to be 0. So all I'll be left with is the 3 over the negative 15. So I'm going to get y equals, you could either leave it as a 3 over negative 15 or a negative 1/5 or a negative 0.25 or negative 0.2 rather, whatever you want, right? Any of those are fine. You could leave it as a negative 3 over 15. That's fine. Doesn't matter. Okay, so again, that's how I get the y-intercept, right? So for y-intercept, I generally just have to plug into the standard form. There's no reason to make it more difficult. And I get this, which gave me that negative 1/5 or negative 0.2, right? Whatever you want. Okay, so for the horizontal asymptote, right? The horizontal asymptote is about looking at the degrees of the two functions, since both of them have a degree of 2, right? So my horizontal asymptote is going to be the leading coefficients as a fraction, right? So 2 over 1, right? So I'm just going to have a horizontal asymptote of y equals 2. And there will not be a slant asymptote because, remember, you can't have both a slant and a horizontal asymptote. It's one or the other. So in this case, we have a horizontal asymptote at y equals 2. So that's everything I could figure out using standard form. If we switch back to the highlighter for a sec, I'm going to use factored form to find all 4 of these things, right? So now we're going to go ahead and factor. Get a slightly smaller pen because that'll work a little bit better. So if we go ahead and factor this, so I would suggest if you look at this, the numerator has a leading coefficient that is not a 1. It's going to be slightly harder to factor. One of the binomials is going to have a 2x, the other one's going to have an x, right? But what I'd suggest is that you start with the one on the bottom first, because the bottom one is going to be easier to factor, right, because it's just an x and an x. And you know that it's very likely that this problem is designed so that something cancels. So if you can factor the bottom, then that can inform your decision on how you factor the top. So when I look at the bottom, I see that 15 is probably a 3 times 5. Although there are other options, it's likely a 3 times a 5. And I know they have to have opposite signs. So I realized pretty quickly that I need a plus 5 and a minus 3. That's how I'll get that positive 2x, right? And you can check that when you FOIL. You get an x squared. Outer is a minus 3x, and inner is a plus 5x. And my last is a negative 15. So that checks out. That means it's really likely that there's either an x plus 5 or an x minus 3 on the top. So I look at the top and I say, okay, this has to be a 1 and a 3. They have to have the same sign, and that sign has to be negative. Well, since I know one of these is a 1 and one of them is a 3, it's very likely that the 3 is right here, because I want to have a factor that cancels. In most of these problems, you're going to have a hole, and not always, but most of the time. And sure enough, if I FOIL to check, I get 2x squared, that's right, a minus 6x and a minus 1x, that's my minus 7x, and a plus 3. So once I have that, right, I now know that this is the factor that cancels, right? So this is going to be a hole at x minus 3 is 0, which gives me x equals 3, right? So x equals 3 is a hole, right? I'm going to have a vertical asymptote at the denominator factor that doesn't cancel. So x plus 5 is 0, which means my vertical asymptote is x is negative 5. That allows me to find my domain, right? The domain is all real numbers except those two numbers, right? So x is an element of reals. X can't be a 3 or a negative 5, right? It can't be those two things, the two things that would make the denominator equal to 0, right? And then for the 0, it's going to be this value up here. So my root is going to be 2x minus 1 is 0, so x is a 1/2. All right, so the last thing I should do is I should write my simplified form, which is what happens when I cancel the x minus 3's. So you don't have to write the simplified form, but it's much easier to recognize that this graph will look like this, because when I go to make my table, that's going to make life a lot easier. So let's think about what we need on our graph, right? So we just need to start by making a table around the vertical asymptote. The vertical asymptote is at x equals -5. Oh, sorry, there's a bunch of math under there that I didn't realize was there. All right, so if we go ahead and make our table, right, the vertical asymptote's at -5, so my table of values should be centered around that vertical asymptote at -5, right? So there's a vertical asymptote at -5. I need a couple points to the left of -5, so I'm going to pick -6 and -7, right? I need a couple points to the right of -5, so I'm going to pick -4 and -3, right? Those are my x values, and then my function was 2x minus 1 over an x plus 5. That's the simplified form that I'm plugging into, right? So when I plug -7 in, right, I get a -15 on top and a -2 on the bottom. So that's a 7.5, right? When I plug in -6, I get a -13 on the top and a -1 on the bottom. So that's a 13. When I plug in -4, I get a -9 on the top and a 1 on the bottom. So that's a -9. When I plug in -3, I get a -7 on the top and a 2 on the bottom. So that's a -3.5. So it looks like I need y values as high as 13 and as low as -9, which is a pretty big window. And it looks like my x-axis can be pretty far to the right over here because I need mostly negative x's, right? The largest positive x I see is that there's a hole at x equals 3. So I'm going to go ahead and draw my y-axis here. I didn't mean x-axis, by the way. I'm sorry. I said x-axis a second ago, and I meant y-axis. And there we go. All right, so go ahead and draw our y-axis, right? And then I need some pretty big positive and negative values, and this grid might not be enough for me to deal with it. One way to get around that is to go by 2's on the y-axis, because it does look like I need some pretty big values, and I don't really seem to have enough room for them, right? So I didn't get a big enough grid. So I need to go up to 13 and down to -9, and I just don't think that this grid's going to accommodate that. So one way to get around that is to go by 2's on the y-axis. So let's go ahead and do that. So I'm going to just make it clear that that's 2 and 4. So in the y direction only, we're going by 2's. In the x direction, I'll still go by 1's. Okay, so once I have that on here, I need to start with my asymptotes, right? So here's x is -5, right? That's a vertical asymptote at x is -5. I have a horizontal asymptote, which we'll do, I guess, in purple, right? I have a horizontal asymptote at y equals 2. Now remember, y equals 2, because the y-axis is going by 2's, y equals 2 is going to be right here, right? So that's my horizontal asymptote. All right, so let's plot some points. All right, points that we know. We know that there is a 0 at 1/2, right? So x is 1/2 is a 0, right? So that guy's on there, right? We know that the y-intercept is -1/5, which is pretty small because we're going by 2's here. So -1/5 is like somewhere in there, right? There's my y-intercept, right? We know that when I plug in -3, I should get a -3.5. So here's -3. And that's going to be, so remember, go by 2's. So this is -3.5-ish is somewhere there, right? When I plug in -4, I'm supposed to get a -9. So 2, 4, 6, 8, 9 is somewhere around there. Okay, so that's enough dots to make a pretty smooth branch over there. On this side, when I plug in -6, I get 13. When I plug in -7, I get 7.5. So here's -6, 2, 4, 6, 8, 10, 12. So 13 is going to be right there, right? 2, 4, 6, and that's 8, so 7.5 is going to be somewhere in there. Okay, so when I draw my nice smooth branches, right, so the branch is going to run along the red dotted fence, and it's going to run down here along the purple, right? So I get a branch that looks sort of like this, right? Over here, this branch is going to run down along the fence, right? So you're picturing like a dog running along a fence. And it doesn't have to be perfect, so I'm going to go like this. Now, notice that when I get to 3, and if you don't spot this ahead of time, you don't have to do it ahead of time, but when I get to 3, wherever I would have drawn the graph, there's going to be a big open circle for a hole. Again, if you don't notice that till after you've already drawn your graph, that's fine, right? If that happens, then after you've drawn your graph, you're just going to put a big circle there, and you can put a little note if it's unclear. So cool. so once I'm there, let's go ahead and see what happens if we graph. So if we put this in to check and see if we have an accurate graph, it's 2x to the second minus 7x. And remember, you always want to put the original in because if you made a mistake, you don't always know what step you made the mistake in, right? And it's very common that we make mistakes, but since you're not always sure where you make the mistake, you don't want to use a later version of the equation that you simplified, because what if you simplified that wrong? All right, so that looks good. Let's go ahead and see what happens when we graph. Right, and you can see that sure enough, this is shifted pretty far over. Most of the important stuff in this graph is happening in quadrant 2 and quadrant 3. So if we want to check that our whole is correct, since we already know that the whole should be at 3, we can check by doing trace and then 3 and see if we get an empty space, which we do. If you want to check if your vertical asymptote is correct, you could do trace and try that value of -5, and sure enough, you'll see that we don't have a y value because there's an asymptote. Now, some of your calculators are going to show the asymptote, like some of your calculators will actually have a line here of some, and that just has to do with sort of like the pixels, the way it's graphed. Don't worry about it. If there's this weird missing empty space, that's fine. If there's kind of a vertical line there that looks like an asymptote, that's also fine. All right, cool. So let's move on. All right, same task in example 3, right? The only difference is that I've changed up a little bit of what we're looking at in terms of difficulty. Okay, so again, I'm going to suggest that you start by doing the stuff that you can do with the standard form, right? So I can plug in, so if I plug in for the y-intercept, right, a thing's going to happen that's not ideal. So if I plug in for the y-intercept, I'm going to plug in and I'm going to get y equals a 12 on top and a 0 on the bottom, which is not a thing, okay? What that means is that there's no y-intercept. You can't divide by 0. If you get a 0 on the bottom, 0 on the top is a 0 over a 5 is 0. A 0 over a million is 0. 0 on the top is fine. But if there's a 0 in your denominator, something has gone wrong. So in this particular graph, there's no horizontal asymptote. Sorry, no y-intercept, my bad. Okay, now for horizontal asymptote, I look at the degrees. So the top has a degree of 1, the bottom has a degree of 3, right? So my horizontal asymptote is going to be y equals 0 because the top degree is smaller than the bottom degree. So y equals 0, and there's not going to be a slant asymptote, okay? So that's the stuff that we can get from the standard form. So everything else we're going to have to factor. Let me make the pen a little bit smaller so that we have a little bit more room to work with. Okay, so the numerator, the best I can do is take out a GCF of 3, right? In the denominator, I have a GCF of x, and what seems to be left after I do that is a difference of squares, right? Which is convenient because if you look on the top, there's already one of those factors on the top, right? So if I factor the bottom, I'm going to get in x times an x plus 4, x minus 4, and sure enough, that means that I have a whole. So I have a whole at the factor that cancels, so there's a whole at x equals -4, because I set x plus 4 equal to 0 and solved, right? There is a vertical asymptote at any factor in the bottom that doesn't cancel. So there's going to be a vertical asymptote when x is 4, because I set x minus 4 equal to 0 and solved, and also a vertical asymptote when x is 0. So there are 2 vertical asymptotes in this graph. All right, and there are no roots, because if I look, the only value on the top that I could set equal to 0 is 3, and that's a lie, right? So there are no zeros. All right, so when we go to do our domain, the domain is going to be all real numbers, except x can't be these 3 things, right? So 4, 0, and -4. All right. So this is going to be a little bit trickier to graph than some of the other stuff that we've been doing because of these 2 asymptotes. So let's go ahead and get to it. So when we go to pick our points, we're going to need to pick points on either side of both the 0 and the 4. All right, so I have a vertical asymptote at 0, and I have a vertical asymptote at 4. So I'm going to pick all of the points in between 0 and 4 just because there aren't that many of them. We need a -1 and a -2. We need some things on the other side of 4, so we'll pick 5 and 6. Right, now when I use my simplified form, it's going to cancel the x plus 4s. So my simplified form is just going to be a 3 on top of an x times an x minus 4. That's the form I'm going to use to plug in, okay? So we have a 3 on top of an x times an x minus 4. And I'm mostly recopying it because I don't want to have to keep scrolling up every time. All right, so let's go ahead and plug some values in. So when we plug in, so it's going to be a 3 on the top every single time, right? Because they're all just 3s. When I plug in the -2 on the bottom, I'm going to get a -2 times a -6, which is a 12. So I get a 1/4 or a 0.25. When I plug in -1, right, I'm going to get a -1 times a -5. So that's a 5. So that's a 0.6. Right? When I plug in a 1, I'm going to get a 3 on top of -3, which is a -1. When I plug in a 2, I'm going to get a 3 on top of 2 times, sorry, my brain flaked for a sec, 2 times -2, which would be a -4, so that's a -0.75, right? When I plug in a 3, I'm going to get a 3 on top of a 3 times a -1, so that's a -3, so I get -1 again, right? When I plug in a 5, I'm going to get a 5 on top of, this will be a 5 times, sorry, not a 5 on top, a 3 on top of a 5 times a 1, which is a 5, so that's a 0.6, right? When I plug in the 6, I'm going to get a 3 on top of a 6 times a 2, which is a 12, so that's a 0.25. All right, so let's go ahead and draw our stuff on our graph. If you notice, none of the y values are huge. In fact, if anything, they're all very, very small, right? So if you look at my y values, they're all pretty small. When I go ahead and put my asymptotes on, so, or rather we'll do my axes first. So it looks like I need mostly points sort of right around the y-axis, so I can put the y-axis pretty much right in the middle. That should work fine. So there's my y-axis, and my y values are all pretty small, positive or negative, so I can probably go ahead and put the x-axis pretty much just in the middle as well. All right, so my asymptotes are at 0, right, which is easier to see because I'm doing it in a different color. If you were doing it all in the same color, you might want to just label it the way I am at the bottom, where you say, hey, that's a vertical asymptote. Sorry, it should have been dotted. I usually dot them. It's just a little bit hard on the axis. So, so you can kind of do that, right? Vertical asymptote. All right, and then at 4, vertical asymptote, right? So vertical asymptote at 4. Again, not a bad idea to label them. My horizontal asymptote, which I believe we've been doing in purple, is at y equals 0, which again is hard to see because it's on the axis. So you might want to note it on the side, especially I'm doing it in different colors here, but if you're doing it in one color, it's hard to see. So this is one of those weird spots where a lot of crazy things are happening. So let's go ahead and plot some points. Here's stuff we know. We know that there are no zeros, which kind of fits with the horizontal asymptote, right? So there are no zeros. We have points at -2, comma, negative, 0.25. So -2, comma, 0.25. So here's -2, 0.25, right? And at -1, comma, 0.6. So here's 0.6. So that pretty much tells me that this is going to be a branch up here in this section of the fence, right? So if you don't spot the hole, so I'm actually going to, I see that the hole's at -4, but I'm going to pretend I don't see it for a sec. If you don't spot the hole, you're going to draw the branch first. Okay, you're going to draw the branch first. We'll deal with the hole in a second. So you draw the branch. Then you plot some more points. You see that at 1, there's a point at -1, then -0.75, then -1 again. So at 1, we have a point at -1, then -0.75, then -1 again, right? So again, dog usually runs in the fence. If we were going to cross the horizontal asymptote, the place we would do it would be here, right? If we were going to cross the horizontal asymptote, the place that it would happen would be in this window in the middle, but here it doesn't, and you can kind of spot that also because there are no roots, right? If we were going to cross the horizontal asymptote, then there would be a root in this case because the horizontal asymptote is y equals 0. So last one, 5 and 6, we have the 0.6 and the 0.25. So at 5, we have a 0.6, and then we have a 0.25 again. So it seems that this branch goes here, right? So then we'll verify this in a sec. So the last thing I have to remember to do is I need to remember to put my holes in the graph. Well, if you forgot to put the hole, because I think that's pretty common, right? You're going to find -4, so you're going to go back 1, 2, 3, 4. You're going to go up to where the spot in the graph should be, and you're going to put a hole in the graph, right? And if you did it like this and you didn't have a pencil or you weren't able to do it, you're just going to clearly be like, look, there's a hole in that spot where the path is running. There's a hole at -4. So let's go ahead and look at what this graph looks like and see if it turned out right for us. So on the top, I have a 3x plus 12, all in parentheses, divided by, on the bottom, I have an x to the third minus a 16x. Right? And we'll double check that that's all right. And then we're going to go ahead and hit graph and see what it looks like. And sure enough, that's pretty much what our graph looks like. If you want to check that your holes and asymptotes are right, you can hit trace and try -4 and see if there's a hole. And sure enough, there is, because you can see there's no y value there. You can hit trace and see what happens if you hit 0, and sure enough, there's a vertical asymptote, no y value. And you can hit trace and try your other asymptote at 4, and sure enough, there's no y value. So you can see that our graph pans out just fine. All right, cool. We're going to do one last problem, and that'll be it for this video. All right. So we have x cubed minus 7x squared plus 12x over an x cubed minus 9x. All right, so the first thing I'm going to do is do the three things that I can find with the standard form that I already have, right? So let's start with the y-intercept. Oh, sorry, I usually use a different color for that. All right, so let's start with our y-intercept. Okay, so for my y-intercept, that means I plug in x is 0. Well, you'll spot really quickly that if I plug in x is 0, right? So if I try to get my y-intercept, which means I'm plugging in x is 0, I'm going to end up with a bunch of zeros on the top over a bunch of zeros on the bottom, and that's 0 over 0. So there is no y-intercept, okay? There's going to be a hole there in all likelihood because it's a 0 on top of a 0. So in the last example, you'll spot that we had a number on top of a 0, and that ended up being a vertical asymptote. But if we get 0 over 0, what likely is going to happen is that mystery factor that's causing the problem is going to cancel. So there's a hole here. So it means that there will be a spot where this graph crosses the y-axis. It's just that it's going to be a spot with an open circle. Okay, so there's no y-intercept. For my horizontal asymptote, I look at the degrees and spot that they're the same. So it's going to be a 1 over a 1, just a fraction of the leading coefficients. So it'll be y equals 1, and there won't be a slant asymptote. All right. So let's go ahead and do the stuff we need for our factored form. So I noticed that this thing has a GCF, and you might want to even just factor right above this and spot that it has a GCF. So I can yank out the x, and I get an x squared minus a 7x plus a 12. And on the bottom, if I yank out an x, I get an x squared minus 9, which is a difference of squares. So I get a GCF of x on the top, and then I'm pretty sure that the 12 is going to factor into a 3 and a 4, and that they're both going to be negative. So x minus 3, x minus 4. And you should double check. I get x squared when I FOIL, which is correct. I get a minus 4x and a minus 3x, which is a minus 7x, and I get a plus 12. Again, I'm not going to check that you check. But if your factoring is wrong, there are going to be consequences in problems. It's going to cause this whole avalanche where one thing makes everything wrong. So please check your factors in your head. You don't have to physically do it. I check it every time, and the few times I don't, I regret it because it doesn't pan out, so you should check. All right. So x equals 0 is a hole, which we already kind of suspected because look, when I plugged in x equals 0, I got this 0 over 0. So there's definitely a hole at x equals 0. There's also a hole at x equals 3 because if I set x minus 3 equal to 0, I get x equals 3 is also a hole. So there are two holes, one at 0 and one at 3. The only remaining factor on the bottom that didn't cancel is a vertical asymptote. So that's going to be when x is negative 3, right? Because I said x plus 3 equal to 0 and solve. So x is negative 3. And that gives me my domain. It's all real numbers, except x can't be 0, 3, or negative 3, right? It can't be these three things. Cool? All right. Lastly, my 0 is any factor on the top that doesn't cancel. So my 0 is going to be when x minus 4 is 0, which is x is 4. So I get a root or a 0 at x is 4. When I simplify, I can cancel a bunch of stuff, and my simplified form just ends up being an x minus 4 over an x plus 3, and that's the form I'm going to use to make my table. So x minus 4 over x plus 3. Going to go ahead and write that before my brain forgets what it is. Okay, so I need to make sure that I put my vertical asymptote in the middle of my table. So that seems to be a negative 3 is the vertical asymptote, right? So when I put my values here, I need a couple values on either side of negative 3. So I'm going to go ahead and pick a negative 4 and a negative 5 to the left, and I'm going to go ahead and pick a negative 2 and a negative 1 to the right. So when I plug in my points, negative 5 is going to give me a negative 9 on top of a negative 2, which is a 4.5. Negative 4 is going to give me a negative 8 on top of a negative 1, which gives me an 8. Negative 2 is going to give me a negative 6 on top of a 1, which gives me a negative 6. And negative 1 is going to give me a negative 5 on top of a 2, which is a negative 2.5. So it looks like the biggest y value I need is an 8, and the smallest is a negative 6, and I should probably be able to make that work just barely with my table or with my graph the way it is. It looks like the x's that I need are largely to the left of the y-axis, although I do seem to need x's as high as 4. So I'm going to go ahead and put my y-axis pretty much in the middle. because I think I have plenty of room for my left and right motion. For my x's, I really do want to get as high as let's say an 8 and as low as a negative 6, and that might be a little bit hard on this, but I'm going to go ahead and put it basically in the middle, and then if I have to count down a little bit below my grid, so be it, and we'll survive. It won't be the worst thing in the world. Or you can go by 2's. I guess that's the other option. So we can do what we did before if you want to go by 2's on the y-axis. Either of those is fine. Again, if you don't mark a scale, the assumption is that you go by 1's. So my x-axis assumption is by 1's, but if I mark the scale on the y-axis as 2, then that's fine too. All right, so let's go ahead and plot our asymptotes. So my vertical asymptote is at -3, right? So there's my -3 vertical asymptote, right? My horizontal asymptote, which we've been doing in purple, is at 1. Now remember, 1's going to be halfway between these hash marks because I went by 2, right? So there's a horizontal asymptote at 1. Cool. All right, so now when I plot my points, at -5, I seem to have a 4.5, right? So here's -5, and this is 4, just a hair over 4, because remember I went on a scale by 2's, so 4.5 will just be a hair over that. At -4, I am up at 8, right, which is here, because I went by, here, because I went by 2's. Sometimes my brain is not as functional as it should be. Okay, cool. All right, so at -2, we're down at -6 and -2.5. So -6 would be here, and -2.5 would be somewhere around here, right? Just a little bit below -2. Cool. So now right away, and if I plot my other points, I know there's a 0 at 4, right? So we already have, so that's my 0 at 4, right? And I don't have a y-intercept, which is relevant, right? Now, interesting thing, you can find the y-intercept whole. So I can find the y-intercept whole by plugging into the simplified version, right? If I plug in x equals 0 into this x minus 4 over x plus 3, I get that specifically, right, I'm going to get y equals -4/3 as the whole. So if you want, you could go ahead and get ahead of that and say, hey, there's a whole at -4/3, which is like right about here. Okay, that's fine. I'm going to point out that it really doesn't matter if you do that because you would have found that out anyway if you just connected the dots, right? If you connect the dots, you're going to get that this looks kind of like this, whether you have that hole in advance or not. And then you're going to put the hole at 0, and you're going to put a hole at 3. And again, if it's unclear on your graph, you can totally be like, hey, Hogan, those are holes. I draw poorly. And that's fine, right? And then I go ahead and draw the branch on the other side. And it's going to look something like this. So we'll go ahead and graph it and confirm that we're right. So if we go to y equals, my numerator is going to be an x to the 3rd minus a 7x squared plus a 12x divided by, in parentheses, we have an x to the 3rd. And again, use the original version. I know it's tempting sometimes to use a modified version, but you don't know if you messed up if you use modified version. Also, if you graph the simplified version, it won't give you the holes because what you've done is canceled the holes. So let's go ahead and graph. All right, and that jives with what we're seeing. If we hit trace, we can check that our values are right. If you hit trace 0, you're going to get a hole, right? If you hit trace 3, you're going to get a hole, and you can see there's no y value. And if you hit trace -3, you should get that vertical asymptote, right? So that kind of gives you an idea. All right. So that's how we graph rational functions, and we could certainly use a calculator to check and help us, but that's the basic idea.